Okay, let's unpack this. We all know industrial work has its obvious dangers, right? Sparks, noise. But what about the invisible stuff? The things just floating in the air, maybe impacting people without them even realizing. Today, we're taking a deep dive into exactly that, the often overlooked world of welding fume and gases. Our mission really is to get beyond just defining them. We want to arm you with, the critical knowledge about the risks and how they're managed. So we'll look at what these things actually are, the surprising ways they can affect health, and then the systems in place to control exposure and keep workers safe.
Right, so when you picture welding, it's usually the bright light, the sparks. But the cloud around it, it's incredibly complex, isn't it? We're talking specifically about welding fume here. It's this really intricate mix of tiny airborne particles. And I mean, it's kind of wild. Over 90% of this fume comes directly from the consumable, the electrode, the wire, whatever, vaporizing as it crosses the arc or flame.
Exactly. And what's fascinating, or maybe concerning, is the particle size. We talk about the respirable fraction. These are particles, especially those less than 3 micrometers, 3 millimeters. They're so small. Well, because they're so tiny, they can get right down into the deepest parts of the lungs, places where your body just doesn't have great defenses against them. That's where the risk really increases.
And it's not just the particles, is it? There are gases involved, too. Yeah, a whole range of gases, and they come from all sorts of places. You got like the fuel gases burning, making CO2, maybe carbon monoxide, and the shielding gases, argon, helium, CO2 mixes.
Right. And the heat itself does things. It can break down the flux or slag, releasing CO2 and CO, plus the arc's heat or UV radiation acting on the air around it that can create things like nitric oxide, nitrogen dioxide, even ozone.
Oh, wow. And I guess if the metal isn't perfectly clean.
Exactly. Solvents, surface contaminants, they can degrade with the heat and release gases too. It's, as you said, a real chemical cocktail.
So it's this mix of particles and gases.
Yes. And if we connect this to the bigger picture, the actual risk to a welder depends crucially on, well, 3 main things. First, the specific composition, what exactly is in that fume and gas mix. Second, its concentration in the air, how much is there. And third, obviously, the length of time the welder's breathing it in. It's this combination that determines the hazard level.
Okay, so let's shift to the health impacts. What does this exposure actually do? Starting with the immediate effects, maybe. Those fine particles we talked about. They can irritate the respiratory tract straight away. You might get, a dry throat, that tickly feeling, a cough. And if the concentration is high enough, it can feel like tightness in your chest, even make it hard to breathe. And here's something I found really interesting. This specific illness, metal fume fever, it sounds exactly like the flu, right? But it's caused by breathing in metal oxides.
That's right. Often things like zinc and copper oxides. It's most common when welding galvanized steel because of the zinc coating.
And the symptoms kick in hours later. First, cough, headache, sweating, aches, fever.
Yes, typically several hours after exposure, but the really surprising part is the recovery. Usually someone recovers completely within a day or 2 after they stop being exposed. No lasting effects, typically. It's a very acute, temporary thing, but definitely unpleasant.
Okay, so that's the short term. What about breathing this stuff in day after day, year after year?
Well, continued fume inhalation over long periods can lead to a condition called siderosis. This is basically iron particles depositing in the lung. Generally, it's considered benign. It doesn't usually cause symptoms or impair lung function itself.
But there are more serious concerns, right? Like cancer.
Yes, that's the more significant long-term worry. There is evidence suggesting welders have a slightly greater risk of developing lung cancer compared to the general population. Now, it's important to be precise here. In some welding processes, the fume might contain specific forms of chromium, like chromium-6, or certain nickel compounds. These specific substances have been linked to lung cancer in other industrial processes, not specifically welding itself.
Ah, okay. So the link isn't directly proven in welding for those compounds.
As yet, no direct causal link has been clearly established specifically for welding fume containing those substances. However, as a, sensible precaution and to minimize any potential risk, it's really important to pay special attention to controlling any fumes that might contain chromium or nickel compounds. It's about being proactive.
And there are other things too, like barium or fluorides?
Yes, sometimes fume contains elements like barium from certain electrodes or fluorides from flux coatings. These have their own potential health effects.
And coatings on the metal being welded, like paint or primers?
Absolutely. The heat can break down surface coatings, potentially releasing toxic substances. That's another layer of hazard to consider.
Okay, let's swing back to gases specifically. What are their distinct health hazards?
Well, some gases are primarily irritants to the respiratory tract. Ozone, for instance, can cause irritation that might not show up immediately, but could later progress to bronchitis or sometimes pneumonia.
And nitrogen oxides.
Nitrogen oxides, like NO2, can cause a dry cough and chest tightness. Again, the symptoms often have a delay, maybe 4 to 8 hours. And in severe exposure cases, they can be extremely dangerous, potentially leading to pulmonary edema, that's fluid building up in the lungs, or pneumonia, which can be fatal.
And then there's the risk of just running out of oxygen.
Yes, asphyxiation. This is a critical concern, especially when welding in confined spaces. Inert shielding gases like argon are heavier than air. They can build up in enclosed areas, push out the oxygen, and you wouldn't even smell it or realize it's happening.
So special precautions are absolutely vital there.
Absolutely. And another asphyxiant is carbon monoxide, CO. If fuel gases don't burn completely, you get CO. It's dangerous because it binds to hemoglobin in your blood much more strongly than oxygen does, essentially starving your body of oxygen.
Wow. Okay, so knowing all these different risks, particles, gases, short-term, long-term, how do workplaces actually manage this? How do we establish safe levels?
This is where regulations and good practice come in. Many countries have systems in place. In the UK, for example, it's governed by CHH, the Control of Substances Hazardous to Health Regulations. A key part of this is setting workplace exposure limits, or WELLs. These are basically maximum concentrations of hazardous substances allowed in the workplace air, averaged over specific time periods.
Okay, so like a speed limit for air contamination.
Kind of, yeah. There are usually two types. The long-term exposure limit, LTEL, often averaged over 8 hours, that's the typical workday, a time-weighted average, or TWA. And then there's the short-term exposure limit, SUTCL, usually averaged over just 15 minutes.
And the SUTCL was 4.
It's designed to protect against health effects that might happen after just a brief high exposure, things like eye irritation, coughing fits, or even narcotic effects from some substances. These limits are published in official guidance, like the UK's EH40 document.
And the regulations, like COHCH you mentioned, they set a fundamental goal, right? I think Regulation 7SAH and COHCH says control is only adequate if, well, basically, if you prevent exposure first and foremost, or if that's not reasonably practicable, control it properly. Prevention is key.
Precisely. Prevention is always the top priority. And to achieve that, or adequate control if prevention isn't possible, we rely on what are often called the principles of good practice. There are usually around 8 of these principles. Think of them less as a simple checklist and more as a whole approach to controlling risk.
Okay. Can you give us a flavor of those?
Sure. The first principle is about designing processes to minimize the emission and spread of the hazardous substance in the first place. Start at the source. Then you have to consider all the ways someone could be exposed, breathing it in, skin contact, ingestion, not just inhalation. Control measures should be proportionate to the actual health risk.
Makes sense. Don't use a sledgehammer to crack a nut, or vice versa.
Exactly. And choose the most effective and reliable controls that minimize escape things. Things like local exhaust ventilation are usually preferred over just general ventilation. And here's a crucial one. Personal protective equipment. PPE, like respirators.
Yeah.
PTE should only be provided when adequate control cannot be achieved by other means, like ventilation or process changes. And even then, it should be used in combination with those other measures, not instead of them.
So respirators are really the last line of defense, not the go-to solution.
That's the principle, yes. It's essential, but it comes after you've tried everything else. Other principles involve regularly checking and reviewing control measures to make sure they're still working effectively. Informing and training employees is vital. They need to understand the risks and how to use the controls properly. And finally, making sure that putting in controls for one hazard doesn't accidentally increase the overall risk somewhere else.
That's a really comprehensive framework. It seems like if employers follow those principles properly...
Yes, if they apply these principles correctly, exposure should generally be controlled well below any relevant well-ill.
It really emphasizes tackling the problem at its source, rather than just relying on PPE.
Absolutely. PPE is there for when those primary controls aren't enough or aren't reasonably practicable. And just to give a couple of concrete examples of those wells we mentioned, for general welding fume, often measured as iron oxide, the UK 8-hour TWA is 5 milligrams per cubic meter. But for something like chromium-6 compounds, which we discuss as a concern, the limit is much, much lower, 0.05 milligrams per cubic meter for the 8-hour TWA.
Wow, that's a huge difference. It shows the specific hazard level.
It does. And for carbon monoxide gas, the 8-hour TWA is 30 parts per million. It's important to remember, though, just because a substance doesn't have a specific WELL listed doesn't automatically mean it's safe. The general CAH principles still apply.
Right. So as we wrap up this deep dive, we've really covered a lot of ground. We've looked at the difference between welding fumes, those tiny particles, and the various gases produced. We've seen the range of health risks from that temporary metal fume fever all the way to potential long-term concerns like lung cancer and the irritant effects of gases. And critically, we've understood the importance of robust control measures guided by regulations like COSETH and those fundamental principles of good practice, emphasizing prevention and engineering controls over just PPE.
Exactly. And this isn't just theoretical knowledge, is it? It's about understanding the practical steps needed to make workplaces genuinely safer. Careful planning, applying these principles consistently, it really can mitigate significant health risks for welders and those working nearby. As they say, knowledge is power, but applied knowledge is transformation, especially in safety.
Absolutely. And that brings us back to you, the listener. Why should you care about the details of welding, fume, and gas? Well, this deep dive gives you crucial insight into industrial safety realities. It encourages thinking critically about those invisible hazards in workplaces. And it shows that complex interplay between science, health, and regulation that shapes safety practices impacting so many lives. So here's a final thought to maybe chew on. How might these principles, assessing exposure, controlling it at the source, using a hierarchy of controls, apply elsewhere? Think about other processes, maybe even in daily life or different industries entirely. What other invisible risks might be out there that, if we took a similar deep dive, we could all understand and manage better?
Our examination appeal service is now up and running. This allows you to take control even when an exam doesn't go your way. So all you have to do to get the process started is head over to our website at www.carbonarc.co.uk, hit training, find your way to the Examinations Appeal Service link, read the description about what's available, start your application process, where we will be able to take some details from you about your exam and send you a PDF that will help bring everything together. At that point, we'll review your appeal, write an appeal document for you to send to your chosen scheme management committee, and hopefully get that examination redone.